Hello everyone. In previous video we seen assignment question solution of data science question number 1 and 2. Now we will discuss third question. Explain the purpose of training, test and validation set in machine learning. What is cross validation and how does it differ from a simple train validation test split? So training data is data which is used to fit your model or the set used for learning. Validation data is data used to tune the parameters of a model. Test data used to evaluate the final model's performance after training and tuning. The model should never be trained or tuned on this data. It is only for final testing or performance evaluation. Cross-validation. Cross-validation refers to a class of methods that estimate test error by holding out a subset of the training data during the fitting process. First, validation set approach. The data set is split into two parts, training set, validation set. The model is trained on the training set and tested on the validation set to estimate performance. Common example 80 to 20 split, 80% training, 20% validation. Second is leave one out cross validation. The data set is split such that the validation set has only one observation. The model is trained on the remaining n-1 samples. This process is repeated for every observation. The test error is the average of all these individual test errors, very accurate but computationally expensive. Third is k-fold cross validation. The data set is randomly divided into k groups of faults of approximately equal size. One fold is used for validation and the remaining k-1 fold for training. Repeat this process k times, each time changing the validation fold. The average of the k-test errors gives the final performance estimate. For example, 5-fold CV or 10-fold CV are common choices. What is the difference between simple split and cross validation? Data is split once and data is split multiple times into folds. Accuracy estimate may vary depending on the random split, more reliable and stable estimate. Now computation cost low and it is high. Best for large data sets and cross validation is best for small or limited data sets. So we have question number 4. Given the confusion matrix, find classification, accuracy, precision, recall, type 1 error, type 2 error, F1 score, sensitivity, specificity. Explain the importance of precision, recall as compared to accuracy with an example. So we can see we have given a confusion matrix. We have given what? Confusion matrix. Now, this is our true positive. This is true positive. This is true negative, we can see. And this is false negative. And this is false positive. So, accuracy is what? TP plus TN upon TP plus TN plus FP plus FN. Putting values, we will get 0.70 means 70% accuracy. Precision is nothing, just positive predicted values. So TP upon TP plus FP, which will be 0.75, 75% precision. Recall, recall and sensitivity are both same. So recall is equals to TP upon TP plus Fn. We will get 0.6 means 60%. Specificity, true negative rate. So specificity is Tn upon Tn plus Fp. We will get 0.8 which is 80%. Type 1 errors, false positive rate. So type 1 error is equals to Fp upon Fp plus Tn which is equals to 0.2, 20%. Type 2 error, false negative rate. Type 2 error is equals to Fn upon Fn plus Tp. 4 upon 4 plus 6, 0.4 which is 40%. F1 score is equals to 2 into precision into recall upon precision plus recall. After putting value, we will get F1 score as 67%. Importance of precision and recall versus accuracy. So accuracy measures the overall correctness of predictions, but it can be misleading when data is imbalanced. Precision focuses on how many predicted positives are actually correct. Recall focuses on how many actual positives are correctly identified. For example, suppose a model predicts whether a person has cancer. If only 1 out of 100 people actually have cancer, A model that predicts no cancer for everyone will be 99% accurate but useless because recall is zero. A good model should have high recall, means catch all true cancer cases, and reasonable precision, means avoid false alarms. Thus, precision and recall give deeper insight into a model's effectiveness for critical or imbalanced classification tasks. So for this video, we have discussed question number 3 and 4, and we will discuss further questions in further videos. So thank you.